And now we can move to the next presentation, which will be about structure. I think we will continue to see, again, very familiar concepts like data set or data structure in this presentation. And this will be given by Catrin and then Mauro Scanu. Mauro is a senior researcher at Istat. He coordinates the activities on institutional system on structural metadata, on metadata harmonization. He is currently working on the system development using GSIM as a reference framework. And Catrin, Mauro, if you are ready, please go ahead.
Okay, do you see everything? So this part of the lecture is about the structure group, and part of it will be made by me and the other part by Catrin from Statistics Sweden, that you all have already heard before. What's the structure group about? This structure group is used to describe and define the terms used in relation to information and its structure. As a matter of fact, looking at the picture below, there are many different concepts included in that, but two main concepts are included here. One is the concept of the data set, and this is just an example of a data set, of an aggregate data set that we can have, that Istat publishes on its website. The data that you see inside it will give you a hint of what a data set is, and all the information that is around it is the corresponding data structure. Now, another important aspect that is discussed in this group is also about the referential metadata set, where a data, which is all the reference information that describes information about the process, for instance, by which the data has been obtained. Here is just an example taken from the Eurostat website, where you can find, for instance, information on the contact, on the metadata update, on statistical presentation, and so on. This is the corresponding referential metadata structure, and the information that corresponds to each of these items is the corresponding referential metadata set. Now, for lack of time, in the next slides, we are going to refer mainly on the data sets and data structures, and you can find all the information about the referential metadata set elsewhere. So what's the content, what's the set of information objects that you will find? As I said to you, two main aspects are discussed. One is about data set, and Catrin will give you more information about this concept and all the related items. The other one is the data structure, and I will give more information afterwards about these items. So I give the word now to Catrin.
Yes, thank you. Right, this is Catrin Karling speaking again. I'm a business architect at Statistics Sweden, and I will talk you through the data set. This picture shows the data set and information objects connected to it in the structure group. A data set is where we keep the data. It could be a table. It's a simple example. A data set is structured by a data structure. That means that the data structure explains what the data set contains. So if you want to know what the data set holds, you should look at the data structure. A data set has one or many data points, which could be a cell if it's a table. A data set is either a dimensional data set or a unit data set. If it's aggregated data, it's often a dimensional data set. A data resource is a collection of data sets. It could be used, it could be data sets for dissemination. A data set is an organized collection of data, and here are a lot of examples. It could be observation registers, time series, longitudinal data, survey data, rectangular data sets, event history data, tables, data tables, cubes, registers, hypercubes, vectors and matrices. A broader term for dataset could be data, and a narrower term for dataset could be element, data record, cell, or field. Yes, and a data resource is an organized collection of stored information made of one or more data sets, and a data resource are collections of data that are used by statistical activity to produce information. And data resource is a specialization of information resource. This is data structure. A data structure defines the structure of an organized collection of data, which was a data set. And the structure is describing using data structure components. And they can either be attribute components, identifier components, or measure components. There is an example here for unit data, which includes social security number, country of residence. The first columns there and the role they play is they are identifier components in this data structure. And then it's age, citizenship, country of birth. And they, in this data structure, they are measure components. A data point is a placeholder or a cell for the value of an instance variable. A field in a data structure which corresponds to a cell in a table. The data point is structurally distinct from the value. So the datum is something else and the data point is just the cell that's holding the data. And the dataset could be either a unit dataset or a dimensional dataset. This describes a unit dataset. It's a collection of data that conforms to a known structure and describes an aspect of one or more units. And synonyms are microdata, yeah, unit data, synthetic unit, record file. The other one is dimensional dataset, which is the other type of dataset. It's often used when data is aggregated. It's not showing a specific unit, but it's aggregated data. This is showing the income, household's main income source. Right, and then.
Okay, now it's time for me to describe these other objects. Catrin already described what a data structure is, and as a matter of fact, the idea is to now to give the components, what are the elements that describe the data structure itself. And here there is written the fact that there are three main elements that should be considered in order to describe a data structure. And the Catrin already introduced them: the identifier component, the measure component, and the attribute component. Now I can already say something about a question that was done before, something about SDMX. For those that already know this kind of standard, SDMX, they can see that the corresponding data structure definition has a perfect mapping with what happens here in the generic statistical information model. There is an identifier component, a measure component, and attribute component. All these elements in SDMX need to be defined by concept schemes. Now, what is the value added, for instance, that GSIM is going to give here? What we are going to say now is that all these elements, identifier component, measure component, and attribute component, refer to a specific class of concepts that are all represented variables, with all the elements that characterize represented variables that have already been introduced by Catrin and Mikko in the lecture before. So let's go and specify better what an identifier, a measure, and an attribute is. The identifier component, as I told you, is a represented variable, and its objective is to identify the unit in an organized collection of data. The examples now refer to the two different data structures that Catrin already introduced, the unit, data structure, and the dimensional data set, sorry. As far as a unit data set, an identifier component can be given by a personal identification number, for instance, of a Swedish citizen. And also the fiscal unit that was introduced before, I believe, can be a corresponding represented variable that can act as an identifier component in some unit data sets. If we are going to see, on the contrary, a dimensional data set like the ones published by Eurostat and so on, the name of a country in the European Union is an identifier of the data that is inside there. As far as the measure component of the data sets, whatever they are, even unit or dimensional data sets, these correspond to a represented variable that is going to describe what's the real, what is exactly observed on the unit or groups of units that are included in our data sets. For instance, here we have a unit data set, age, and a unit data set referring to a unit type person. Then the age and height of a person is what we are going to measure inside the unit data set. If we are going to have a data set for multiple countries, for instance, what we measure on these countries corresponds to the number of households or number of citizens or whatever. And as far as an attribute component is concerned, this is the role given to a represented variable which supplies information other than identification or measures. These are two examples taken from the GSIM specification document. The embargo time, at which point the observation will be made publicly available. This corresponds also to something that was asked before in the other lectures. The base period of the data in the series, but for instance also the unit measure if unit of measure if something like that is not expressly represented inside a represented variable. So, Catrin, what about an example of unit data structures?
Yes. Yeah, this is just an example, simple example of a unit data structure. The unit type is person, and the population in adults in Sweden 2018. It should probably be a date there too, like 31st of December. Mm-hmm. And in this table, the represented variables are person number, income, gender, marital status, and quality. The identifier is the personal number. It identifies a unit in this table. And the measures are the income, the gender, and the marital status. And then there's an attribute there on the side saying something about the other represented variable, if the quality of the data is good or not.
Okay, now I give on the contrary an example for dimensional data structure. This is again the example I introduced at the beginning. It represents the annual average household's income, and this information is also given according to the different regions in Italy and the different kinds of households' main income source and the number of components in the households and according to the time of the reference time. So what are we talking about in this table? What are the concepts that have been used up to now? The unit types that this table refers to is the households. The population consists of the households resident in Italy in 2016. As a matter of fact, you are right, we should add also a specific date for it. And the represented variables that have been used are all the names that have been given in boldface in this table: territory, household main income source, number of components, time, and annual average income source. What's the representation in terms of data structure of these represented variables? The identifiers here what are we going to identify? As far as the households is concerned, this is something that describes what happens on an aggregate data sets. And in this case, the aggregates consist of groups of households. So the combination of the code lists attached to these concepts, territory, household name, income source, number of components, and time, is going to give us information on the group of households the single cells are going to refer to. And on these groups of households, something about that is measured, and it's the annual average households income. So this other element is what we measure on the group of households that we are going to refer to. And the attributes, here are two examples of attributes. For instance, why the element is missing, if the data which has been given here is provisional or not. But in this case, also the fact that the number that are included in the table are expressed in euro, so it's the unit of measure, it is an additional attribute we can also consider here. So it's an additional represented variable to consider. So in order to close this talk, this part of the talk, we can say that there are many other objects that are described in the model. It consists of 26 information objects. And you can find more information on the documentation.